Hello, I'm Tana, your MLC tutor. So this video is on percentiles of insurances. I had a viewer request this topic, so if this is not what you had in mind, please let me know and I will do something else. This is a sample exam question. They tell us that we are looking at a 10-year deferred whole life insurance on a 35-year-old payable at the moment of death. So I have that down just to remind us of the context. The force of interest is 10% and our force of mortality is constant at 0.06. They define Z to be the present value random variable. So the present value of our insurance, which we're estimating based on mortality assumptions. And we want to find the 90th percentile of Z. So the 90th percentile of Z will be whatever value of Z, whatever present value of our insurance, is the point that separates that 10% of the largest Z values and the 90% of the lower Z values. So the first thing to note is that the larger present values of this insurance will be associated with death times that are sooner, because if they die, if they die 50 years from now, the present value of that insurance is going to be smaller than if they die 15 years from now. So for larger values of T, the insurance, the present value of the insurance will be smaller because the benefit is getting discounted back farther, generally. Here we have a 10-year deferred insurance, so we have to note that in the first 10 years, and I have a graph here, this would be the Z, which is the present value of the insurance, and the future lifetime of our X-year-old. So in the first 10 years, since it's a 10-year deferred insurance, the present value of the insurance is nothing. If you die in the first 10 years, you don't get anything. It's going to be at the highest point at time 10, because that's when the insurance starts. If you die right away, you get the benefit right now and it barely gets discounted at all. So that's going to be the largest point. And then it gets smaller as T increases because at each of these death times it's getting discounted back a little bit farther, a little bit farther. So the 10% of the largest C's will be associated with some times between 10 and some point T. So now we want T such that the probability that you live 10 years and then die in this next period here before T is 10%. So let's see, you live 10 years and then this interval here is T minus 10. So you live 10 years and then die in the next T minus 10 years. I guess it's for a 35-year-old. This is equal to 10p35 minus tp35. So you live 10 years, but not t years. We want that to be 10%, so 0.10. Because we know that that's where the 10% of the largest values of our z will be. This is where the 10% of our largest present values of our insurance will be. So, because I have a constant force of mortality, I know that 10p35 is e to the negative 10 times 0.06. TP35, the probability that that 35-year-old lives t years, will be e to the negative t times our force of mortality, 0.06. Okay, that equals 0.1, or 10%. I can solve for t, and you should get 13.3525. Okay, so this is the time that's associated with the largest 10% of the z values. So the largest 10% of the z values fall between time 10 and time t. But that doesn't tell you what the 90th percentile of z is. It doesn't tell you what the 90th percentile of the present value of our insurance is. But since we have that t, we can use that to find the associated present value of the insurance at that point t. So the present value of this insurance that pays at time 13.3525 will just be e to the negative, or force of interest, times 13.3525. We're looking for the value of an insurance that pays a benefit of 1 here at this point t. So v to the t is going to be e to the negative force of interest times the t that we found that is associated with that period in which we have the largest 10% of z values. So this e to the negative 10 times, or e to the negative 0.1 times 13.3525 is 0.2631. And that will be your 90th percentile for the insurance. If anything about that wasn't clear, please let me know. I would be happy to do this again. Take care and happy studying.